Our next section is titled Solution, Stoichiometry, and Chemical Analysis. And I really like this section because we're going to start to pull together concepts that we learned throughout the last couple chapters and the first section of this chapter and blend them all together. So the same concepts involving stoichiometry and balancing chemical reactions can be applied to solutions. So we can use all of these topics to start solving more advanced problems, and you're now going to see in your textbook homework problems that we're going to call integrated exercises, which blend together all of these topics that we've been discussing. So let's do an example of this, and we're going to ask what volume of 0.215 molar HCl is required to neutralize 0.685 grams of barium hydroxide. So this is going to bring up several topics that we've talked about before. We need to recognize that we have an acid and a base. And when we react an acid and a base, the products are going to be a salt plus water. So we have HCl plus barium hydroxide, which is BaOH2. We need to be able to predict the products of this reaction to solve this particular problem. So our products are going to be BaCl2 plus 2 H2O. And in order to balance this particular equation, we need a 2 in front of the HCl. So now that we have this particular reaction balanced, we know it's a neutralization reaction, and we know that for every 1 mole of barium hydroxide, we're going to need 2 moles of HCl. So we'll start with our given quantity, which is 0.685 grams of BaOH2. We know from the periodic table that 1 mole of BaOH2 is equal to 171.34 grams of barium hydroxide. We know from our balanced chemical equation that for every 1 mole of BaOH2, we need 2 moles of HCl in order to neutralize this. We're given a concentration of 0.215 molar HCl. So that means we have 0.215 moles of HCl per every liter of solution. So when we go through and calculate this, we get 0.0372 liters. Or if we were asked this quantity in milliliters, which is probably what you're going to have to do, this is going to be 37.2 milliliters. So we can use a couple concepts knowing about neutralization reactions and using solution stoichiometry to determine how much or what particular volume we would need of, in this case, an acid to neutralize a particular quantity of a base.